Good morning, class.
Good morning, ma'am.
Please stand for a prayer. May I ask Mr. Labata to lead the prayer?
In the name of the Father, and the Son, and the Holy Spirit. Amen.
Our Father in heaven, hallowed be your name. Your kingdom come. Your will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen. You may now take your seat, class. So again, good morning, class.
Good morning, ma'am.
So let's have an attendance first. Who are absent today?
None, ma'am.
Very good. So before we begin our discussion today, I want you to prepare your periodic table and calculator. Please listen attentively and cooperate, for you will receive a corresponding points. Am I clear, class?
Yes, ma'am.
Very good. Now, let's have a review for what was our discussion last meeting. Now, what was our topic last meeting?
Organic compounds, ma'am.
Very good. We talked about organic compounds. So, what are the types of organic compounds?
Types of organic compounds are lipids, carbohydrates, proteins, and nucleotides.
Very good. I'm glad that you are all understand our topic last meeting. So, before we begin our discussion today, I have here a picture. I want you to observe and analyze. Okay, so what have you observed based on the picture?
Ma'am, it measures the amount of the product.
Very good. Can you easily count each pieces?
No, ma'am.
Why is it less?
Because it is too many and too small.
Okay, now, how can we count or measure the quantity of this substance?
By using the scale.
That's great. By weighing the substance, we need to use scale. Then, the units are in either grams, kilograms, liters, and others. So our topic this morning is about quantifying substance. So at the end of the lesson, students are able to explain the concept of mole, calculate problems underlying conversion of mole concept, and state the importance of mole concept. So, how can we quantify substance in the field of chemistry? Through the concept of mole. That's it. Through the concept of mole. So, what do you mean by mole? So, mole is the abbreviation of MOL, which states that mole is the fundamental counting unit of chemistry. So, mole, it talks about counting. So, the concept of mole allows you to count these particles and establish a standard for reactions stoichiometry. And as you know, class, that mole is the convenient unit to use. Why is it? Why is it that the mole is convenient to use? It's because of many number of particles that is present in a certain atom, molecules or ions, that is very difficult to count. Am I understood, class?
Yes, ma'am.
Now, how can you calculate the number of moles?
Using Avogadro's number.
Very good. By using Avogadro's number. As you know, class, that Avogadro's number is invented by the Italian scientist, namely Amedeo Avogadro. And the volume of Avogadro's number is 6.022 times 10 raised to the power of 23. So this is equivalent to 1 mole. Again, what is the Avogadro's number, class? Here, what is the Avogadro's number?
6.022 times 10 raised to the power of 23.
Correct. Now, it is equivalent to?
1 mole.
Very good. So the mole of a certain element implies two things. Take note, class. The mole implies two things. Two things. So what are those? First, the atomic mass expressed in grams is different for each element. This mass is known as the molar mass of the element. So the molar mass of the element. Again, what is the first implication of mole, class?
Molar mass of element.
Correct. Number 2. Avogadro's number of atoms is the same for all elements. Avogadro's number is the same for all elements. Now, we need to discuss first this first implication. Again, the atomic mass expressed in grams is different for each element, and this mass is known as the molar mass of the element. Take note, class, that the molar mass of the element is based only on the periodic table. So here's the example for our first implication. Example number 1. What is the molar mass of cobalt? Anybody?
58.933 gram
Per
Per
mole. Correct. It is
933 gram per mole.
58.933 grams per mole. Correct. How about for our next example? Example number 2. What is the molar mass of zinc? Anyone who will volunteer to answer?
65.39.
Okay, it is 65.39. That's it. The molar mass of zinc is equals to 65.39 grams per mole. Now, why is it, class, you can get this answer?
Because the molar mass is equal to the atomic mass.
That's correct. Because the atomic mass is equals to, the molar mass is equals to the atomic mass. Am I understood, class?
Yes, ma'am.
Okay. Let's proceed to implication number 2. Our second implication states that Avogadro's number of atoms is the same for all elements. Now, 1 mole of any element is equals to 6.022 times 10 raised to the power of 23 atoms. So 1 mole is equals to 6.022 times 10 raised to the power of 23 atoms. Again, what is the second implication state, class? That
1 mole equals 6.022 times 10 raised to the power of 23 atoms.
very good. Okay, let's proceed to the example. Example number 1. How many atoms in hydrogen? Anybody from the class will answer.
Ma'am, 6.022 times 10 raised to the power of 23 atoms.
Very good. It is equals to 6.022 times 10 raised to the power of 23 atoms. So how about, for example, number 2? How many atoms are there in 1 mole of hydrogen? What is the answer?
Ma'am, 6.022 times 10 raised to the power of 23 atoms.
Correct. How about for number 3? I want you, Mr. R, to answer. So how many atoms are there in 1 mole of oxygen?
6.022 times 10 raised to the power of 23 atoms.
Correct. Now, why is it, class? You can get this answer. It's because
This means that 1 mole of any element is equal to 6.022 times 10 raised to the power of 23 atoms.
very good. As what's stated in our second implication. So let's move on to the next one, which is the interconversion of mass, mole, and the number of particles of an element. This time, let us have the conversion about mole concept. So, let us discuss each conversion one by one. Am I clear, class?
Yes, ma'am.
Okay, let's proceed. So, our first conversion of mole concept. So first conversion is about mole to mass. Mole to mass, our first conversion. So our formula here is mole times grams over mole is equals to
Mass.
mass. Correct. Now, where can we get the mole? Asa ni siya nato makitaan? It is based on the given in the problem. Okay. Based on the given problem. How about the grams? Where can we get the grams? So we can get the grams in the atomic mass.
Of the given element
Correct?
in the problem based on the periodic table.
And how about our second mole? We can get this is 1 mole because it is constant. Correct. Now, again, where can we get the mole? Our first mole, it is
Based on the given in the problem.
correct. And how about our grams? Where can we get?
Atomic mass of the given element in the problem based on the periodic table.
Okay, you have to take your class on the periodic table. And how about our second mole?
1 mole because it is constant.
Correct. Now, let's go to our example. What is the mass the mass of, what is the mass of 3.00 mole carbon. So, our given, let's listen class. Our given here, our mole is equals to what?
3.00 mole of carbon.
Correct. It is 3.00 mole of carbon. How about our grams?
12.01 gram.
Why? We can get this 12.01 grams based on the periodic table, which is the grams of carbon. And how about our second mole?
1 mole because it is constant.
Okay, you always take note that it is constant. Now, what we're going to do next? We have to substitute our given in our formula. So it looks like this. Our formula is mole times grams over mole equals mass. So we need to substitute. What is the mole?
3.00 mole of carbon.
Times. What is the grams of carbon?
12.01 gram.
How about our mole?
1 mole.
So you need to multiply the mole times grams, which is 3.00 grams times. 3.00 mole times 12.01 grams divided by 1. So we can get the answer of 36.03 grams of carbon. Am I understood, class?
Yes, ma'am.
Any question?
No, ma'am.
Now, you can try to solve for number 2. Okay, anyone I want volunteer? How about you, Mr. Labata? Yes, you have to try this. I have to write first the example number 2. Number 2, here's formula. Mole times grams mole equals mass. So our problem number 2 states that what is the mass of Okay, our example number 2 is that what is the mass of 6.00 mole of nitrogen? So you can write first here the given before you can substitute to the formula. Am I clear?
Yes, ma'am.
Okay, now please come on the board. Present your answer. Okay, can you explain your answer, please, Mr. Labata?
6.00 times 14.00 gram of nitrogen equals to 84 gram of nitrogen.
Very good. Thank you for your answer, Mr. Labata. So states here that he substitute the given to the formula. So our mole here is 6.00 times the grams our periodic table, which is equals to 14.00 grams, divided by mole, or 1 mole, which is constant. That's why he can get this answer of 84 grams of nitrogen. Am I understood?
Yes, ma'am.
Okay. So he's happy na naka-answer to get the correct answer. So let's proceed. Let's move on to the next conversion. Okay, any question with regards to our first conversion class?
None, ma'am.
Okay. So let's proceed to the second conversion, which is the mass to mole. So here, our formula is mass times mole over grams equals to mole. So we can get the mass based on the given in the problem. And our mole here is 1 mole, which is constant. And we can get the grams based on the atomic mass of the given in the problem based on the periodic table. So, again, where can we get the mass, class?
Based on the given in the problem.
Correct. How about our mole?
1 mole.
Because
it is constant.
correct. And how about our grams?
Atomic mass of the given element in the problem based on the periodic table.
Okay, now, let's try this first example. How many moles are present in 25.6 grams of carbon? So, we can identify here first our given. So, what was our mass? So, our mass is, again, anybody?
25.6 gram.
Okay, as we can see in our given problem of carbon. So, how about our mole? Mole
1
is 1 mole because it is constant. And our grams, what is the grams of carbon?
12.01 gram.
Okay, 12.01 grams. So, what we're going to do is to substitute our given in our formula. So, our formula is mass times mole over grams equals mole. So, our mass here is 6 grams times 1 mole over 12.01 grams is equals to 2.13 mole of
Carbon.
carbon, correct? Because we're going to do here is that the mass is multiplied with mole divided by grams is equals to mole. So here, 25.6 grams times 1 mole divided by 12.01 grams is equals to 2.13 mole of carbon. So we can get here the final answer. Any questions with regard to our first problem?
None, ma'am.
Okay, very good. Let's try to solve for problem number 2. Problem number 2. How many moles are present in grams of 30.00 grams of magnesium? Okay. What is our given here? What is the mass?
30.00 grams.
Okay, correct. 30.00 grams of magnesium. How about our mole?
1 mole.
1 mole. How about our grams? What is the grams of magnesium?
24.305 grams.
305 grams. Okay, now, we're going to do is to substitute our given to the formula, which is, our formula is mass times mole over grams equals mole. Okay, who will substitute the given to the problem? Anyone who will volunteer? Okay, how about you? Okay, come to the board, Mr. Labata. Show your answer and then explain. Is that understood?
Yes, ma'am. So our mass is 30.00 gram times 1 mole over our gram is 24.305 gram equals to 1.23 mole magnesium.
Correct. Thank you so much, Mr. Labata, for your answer. So, we can get the final answer of 1.23 mole of magnesium. You substitute the given here to the formula. Okay, very good. Now, we can proceed to the third conversion. Okay, so our third conversion is the number of particles. Number to mass. So, our formula is number of particles times
Mole.
mole over 6.022 times 10 raised to the power of 23 atoms times grams over mole equals to mass. Now, where can we get this number of particles?
Based on the given in the problem.
Correct. It is based on the given to the problem. How about our mole?
1 mole because it is constant.
Very good. So, it is given here, the letters number. How about the grams?
Atomic mass of the given element in the problem
Okay.
based on the periodic table.
And our mole, our second mole. Where can we get our second mole? Same. It is 1 mole because it is constant. So let's proceed to the example. Here, example number 1. What is the mass of 1.806 times 10 raised to the power of 24
Atoms.
atoms of carbon? So, our given, first, we have to identify the number of particles. So, it is 1.806 0.06 times 10 raised to the power of 24. And our mole is 1 mole.
of carbon.
Yes, of carbon. And our grams, what is the grams of carbon? It is 12.01 grams. And our Avogadro's number is 6.022 times 10 raised to the power of 23 atoms. So, we're going to do is to substitute our given to the problem. So, we're going to substitute now. Okay, so our number of particles is, what's the number of particles?
1.806 times 10 raised to the power of 24.
Times
1 mole.
over Avogadro's number and times what is the grams of carbon?
12.01 gram.
How about our mole? It is 1 mole because constant equals. We're going to do, you have to take note class, to cancel the exponent here, to cancel our exponent, you have to convert one of them. For example, based on this problem, will become 1.806. Why? It's because you have to move to decimal point to the left means addition. And if you move to the right, it is subtraction. So, here in our case, in the first problem, as you can see in our exponent, it is 24. And our Avogadro's number is constant, which is the exponent is 23. So, we're going to subtract by 1 this exponent of 24 in order to cancel this exponent, because we have to match this exponent by 23. So we're going to move in either left or right in order to subtract this by 1.
Right.
Okay, move to right for subtraction.
Yes.
Okay, correct. So we're going to move. So it's gonna be like this. Assume that we move to right side. So we can now cancel this one times 12.01 grams over 1 mole. So anyone try to compute or calculate in your seats. 1.806 times 1 divided by 6.022 times 12.01 grams divided by 1 mole. So we can get the answer of 3.603. Take note, class, that in our exponent, may move to the right side para makasubtract or makancel ang exponential. So for our final answer, again, is may move or makacancel in the right side, correct? So move that to the right side, that's why we can get the answer of 36.03 grams. Any questions?
None, no.
Okay, very good. Okay, let's proceed to the second example. So our problem is what is the mass? What is the mass of 1.106 times 10 to the raised to the power of 24 atoms of carbon? I mean oxygen. Okay, again, I will repeat the question. What is the mass of 1.106 times 10 raised to the power of 24 atoms of oxygen? So, anyone who will volunteer to answer? Okay, correct? Very good. Please come on the board. You have to find first the given and then substitute. Okay, so what is the number of particles? It is
1.106 times 1024 atoms of
oxygen. Our mole, 1 mole. What is the grams of oxygen? It is 16.00 grams. And how about the Avogadro's number? It is 6.022 times 10 raised to the power of 23. Now, you can substitute the given to the formula. So here is the formula. Okay, here's the given, so you can now substitute this given to the formula. Okay, please come on the board. And then please explain your answer. Am I understood?
yes, ma'am.
Okay, please explain.
So our number of particles is 1.106 times 10 raised to the power of 24 atoms times mole over 6.022 times 10 raised to the power of 23 times 6.00 gram
16.
16.00 gram over 1 mole equals to 29.39 gram.
Okay, correct. So, he can get the answer of 29.39 grams. Okay, very good. So, here, come here. You have to cancel first. Cancel, because we moved naman ka to the right side. You forgot to cancel. Okay, cancel here, they. Okay, exponent over and here also. That's why your answer will become
29.39 gram.
okay. Very good. Thank you for your participation. Okay, how about anybody from the class? Any question with regards to this answer of Mr. Labata?
None, ma'am.
Okay, correct. So let's move on to our last conversion. Can I get the chalk, please? Thank you. Okay. Our last conversion is the mass to number of particles. Here, this is our last conversion. So here, our formula is mass times
Mole over gram.
times 6.022 times 10 raised to the power of 23 over mole equals number of particles. So here's the formula. Now, where can we get the mass?
Based on the given in the problem.
Correct. How about the mole? It is 1 mole because it's constant. And the grams?
Atomic mass of the given element in the problem based on the
Okay.
periodic table.
Based on the periodic table. And here is the Avogadro's number, and our mole is number of moles. So, let's try this problem. Problem number 1. How many individual atoms are present in 12.5 grams of oxygen. So, what is our given? What is the mass?
12.5 gram.
Okay, very good. 12.5 grams. How about our grams? How about our grams? Okay, what is the grams? Anyone? Okay, what is the grams of oxygen? It is 16.0 grams. How about our mole? It is 1 mole because it is constant. How about our Avogadro's number? It is 6.022 times 10 raised to the power of 23. Now, we have already the given. So, what we're going to do is to substitute the given to the formula. So, here's the formula. Okay, we're going to do is to substitute now. So what is the mass? Anyone? Based on the given, we have to substitute now.
12.5 gram.
Correct. Times 1 mole. What is the gram?
16.00 gram.
Correct. Times Avogadro's number over 1 mole. What will be the answer? Anybody from the class?
Ma'am, 0.48 times 10 raised to the power of 23 atom.
Correct. We're going to do here is that the mass, which is 12.5 grams times mole, which is equals to 1 mole, divided by the grams of the oxygen, which is equivalent to 16.00 grams, times our Avogadro's number, which is 6.022 times 10 raised to the power of 23 divided by 1 mole. That's why we can get the answer of 0.48 times 10 raised to the power of 23 atoms. Am I correct? Anybody from the question? I mean, anybody from the class? Any question?
None, ma'am.
Okay. I think we're going to move on to our number 2 example. So here, what will be the problem? Okay. Number 2. Our problem states that how many individual atoms are present in lithium? How many individual atoms are present in 10.2 grams of lithium? So based on our problem, what will be our mass?
10.2 gram of lithium.
Okay, 10.2 grams of lithium. What will be the grams? Based on the periodic table
6.941 gram.
of lithium. Add mole is 1 mole and stated that Avogadro's number is equals to 6.022 times 10 raised to the power of 23. So, who will substitute the given to the formula? Any volunteer? Who will volunteer? Anyone?
Ma'am.
Okay, come to the board. And then explain your answer. Here's the chalk. Excuse me. You're welcome. Okay, please explain your answer.
So our mass is 10.2 gram times mole over 6.941 gram times 6.022 times 10 raised to the power of 23 over mole equals to 0.903 times 10 raised to the power of 23 atom.
Of lithium. Okay? Thank you for answer, Mr. Labata. So, anybody? Any question with regards to the different types of conversion of mole concept? Any question?
None, ma'am.
Okay, now, let's have a review. Okay, so, what do you mean by mole class? So, mole is the counting unit of chemistry. So, what are the types of conversion of mole concept? What are the 4 types conversion of mole concept?
Mole to mass, mass to mole, number of particle to mass to number of particles.
Okay, very good. I think you all understand our topic today. So, I think you're all ready for our quiz or activity now. So, let's try this one. number 1, what is the mass of 1.40 grams of carbon? 1.40 mole of carbon. So, anyone who will volunteer to answer for our activity number 1. Okay? Your turn, Mr. Labata. Come to the board. And then explain your answer. Okay, please explain your answer.
R mole is 1.440 times R gram is 12.01 gram over 1 mole is equals to 16.814 gram of
Carbon. Correct. So, his answer is 16.814 grams of carbon. So, what type of conversion is this? It is mole to mass. Is that understood?
Yes, ma'am.
Okay, so I have here a quiz. It is number 1 to 5. So, you can answer this in your paper and then pass this when you're done. I understood?
Yes, ma'am.
Okay, write this in your paper. Number 1. Calculate the molar mass of C5H12. The number 2. Determine the mass in grams of 0.600 mole of oxygen atoms. For number 3. How many moles of magnesium is 2.01 times 10 raised to the power of 22 atoms of magnesium? And for number 4. What is the mass of 1.806 times 10 raised to the power of 24 atoms? And for number 5, calculate the molar mass of 16 grams of oxygen. Okay? Is that clear?
Yes, ma'am.
Okay, so when you're done answering, you can pass this in front. Okay? Am I understood?
Yes, ma'am.
Okay. Are you all done? Okay, pass your paper here in front. If you're done. Okay, you're done. So, thank you for answer. And for your assignment, are you listening?
Yes, ma'am.
Okay. For your assignment, you can read in advance the percentage composition of a compound and give its chemical formula. Okay. Is that understood?
Yes, ma'am.
Okay, I think we are all done for today's discussion. So, thank you class, and again, good morning. Goodbye class.
Bye, ma'am.